Okay, thank you for coming to hear this presentation. Firstly, let me introduce myself a little bit. My first name is Jiaju, my last name is Zhang. I come from China. I have been working with SUSE for about 6 years. In the last 4 years, I have been mainly working on high availability. Currently, I'm leading the server team in China. So today, my topic is geo-clustering for SUSE Linux Enterprise High Availability Extension. So background, you may wonder that why we need to develop such a stuff. Like maybe you think for the traditional HA clusters, it have been very good. So why we need it, and what is the concept of the geo-clustering? So I'd like to get started with the traditional HA clusters. I think although it is good enough for most of the HA requirements, but for some high-level requirements, I think it is not good enough. Like in a traditional cluster, there are some cluster nodes in a local data center. So if some node is down, another node can take over the job. But if we have some disasters, although it is very, very unhappy, but if this unhappy thing happened, so maybe earthquake, fire, or flood, the service must go down. So if we want to keep our service always available, we need at least another site can keep the service always on. So this is the main problem that geo-clustering can address. The other thing is for the storage technology. I think about these 3 years, there are quite a lot of changes in this area. We can see some geo-replication product have been evolved, and we can see that like DRBD proxy can do the replication over a very long distance. And for some commercial products, we also have the geo-replication solution. So data is available, and this is not a big problem as many years ago. So based on these 2 points, we think that some customer may have higher demand on the business continuity. So we can see some products which engage to do the job like site recovery, and we have seen some other company do this kind of job. Basically, our geo-clustering can be seen as a product like the site recovery. And automatic recovery should be a new trend, although there are no mature product, but I think for the next few years, that would become very hot. So for most of these reasons, I think this is the purpose why we develop such a geo-clustering. So introduction. Actually, this concept have been raised in the Linux conference, Linux Plumber conference in 2010. At that time, the Linux cluster community have decided that a key feature for Pacemaker in 2011 would be to improve the support for geo-cluster. We can name the geo-cluster as multi-site clusters as well. So I want to mention that for the geo-clustering, SUSE do most of the development work. We first started the geo-clustering development. And this year, we released the first version of the geo-clustering extension, geo-clustering add-on for our SLE HA product. So basically, this product have most of the basic features which we need in this kind of requirements, but it still have some unimplemented features. I think we will continue the development, and many new features will coming soon. And also we have get some feedback from the community, which is some companies in Japan. So we really have also for the HA community, maybe it is not very big, but we at this field, we really have some customer feedback, user feedback on that. So using scenario. So for a new man which want to use the geo-clustering, or which or who he is don't know how the geo-clustering can meet what kind of needs. So I'd like to share some using scenarios. The first one should be we should for the customer, maybe he have very high demand on the service available. Even if the original cluster was totally broken, he still want his business continue. So if he has this kind of requirements, he may need the geo-clustering. The second one is also a requirements for the customer. So if I think it is this requirements is very apparent that he should have at least 2 sites. So different site has a different local pacemaker cluster each, and the geo-cluster can be seen as a overlay cluster on top of the traditional cluster. So for the customer, he just need to have 2 sites which located in different a long distance between the 2 sites. So if the user have these 2 requirements, I think geo-cluster would be a good option for them. So because geo-cluster is really a new concept, so we introduced some new concept, new terminology in this area. Because for a traditional cluster, maybe like the resource group node, everyone, if he have some experience on the HA cluster, maybe he know all of these concepts. But for the geo-cluster, for some terminology like ticket, maybe you don't know what it is. So the ticket is the main concept we introduced in the geo-clustering. Actually, we named it as token when we first developed this program. But in order to not confuse with the terminology token in CoreSync, so we renamed it as ticket. So basically, the ticket should be seen as a permission that a certain site has the permission to be able to run a certain resource. So in some other products, we may regard this concept as a protection unit. What is a protection unit? Because for some resources running in the cluster, maybe you don't need you don't have the need to let the resources to run in another site. So this kind of resources is not have not the need to be protected in the geo environment. So the protection unit can be a resource group that can fail over between different cluster size. And for the customers, maybe he have different kinds of this kind of groups. He may have many this kind of groups. So we use a ticket to represent this concept. Once I know that we have the ticket, so the next important thing should be how to manage the ticket. So we need a program which can do the cluster ticket management. We call it as a cluster ticket manager, and we also named it as a booth, ticket booth. This name comes from Lars. Okay. Yeah. So we named the cluster ticket manager as booth. So the cluster ticket manager's main job is ticket, like granting a ticket to a site, or revoke ticket from that site, or migrate that ticket from one site to another, or the ticket automatic failover. That means if the original site is totally down, the ticket can be automatically failover to another site. Hence, the related resources will be started on another site. Okay. So the basic idea should be now that we have the ticket concept, we should integrate it into the pacemaker cluster, and which is a cluster-wide attribute in the pacemaker cluster. The next job is, as I have said before, associate the ticket with the protected resources and the recovery plan. The recovery plan, we can see it as we represent it as a CIB, which is a cluster information base in the pacemaker terminology. And so we have all of these concepts. So what we can provide to the customer. One option is we can let the customer, like the admin, to manage the ticket totally manually. This is like some other products, like we just define all the procedure before, and if some site is down, the admin will. So the admin first know this, and then he start up the cluster at another site. So maybe this is a more preferred way currently, but we also provide a automatic failover way that lets the program to decide if the site is down, and if we need to migrate the resources to another site. So if we let the program to do this kind of job, it should be very difficult, because we need the coordination between different cluster sites, and we also need to ensure that the decision is right. So this should be the primary concern of the Geo-cluster. So many policy-related work, it is pretty easy, because we can define a good policy to let the Geo-cluster always running. But for the primary concern, like the ticket ownership decision, this should be a very tough job. Because the Geo-cluster, basically it is the overlay cluster on top of the traditional cluster. We can see the traditional cluster as a node. Oh, sorry. So we should avoid the split brain in the Geo-cluster, like in the traditional cluster. And so to resolve the ticket ownership decision problem, it should be the distributed consensus problem. We have evaluated many of this kind of algorithm in distributed computing. Finally, we selected the Paxos. We can see a lot of papers which say the Paxos, and we can see a lot of projects based on Paxos. So for both, we use Paxos. Okay, this is a simple picture of the Geo-cluster that we have two sides, and for the two sides, the data is synced by the data channel, and for the booth, what we cared is a resource, the availability in resource level. So we have each daemon on different side, and we have another side which named an arbitrator. So basically, these three daemons communicate based on the UDP. Actually, so this is the basic information of implementation of the booth, and the Paxos and the Paxos list implementation is the underlying layer, and it provides the basic mechanism, the distributed consensus service, and the ticket management is something policy related. So we define a own policy which do the ticket automatic failover. And for the transport layer, it should be a basic components which do the network communication. And currently, only UDP is supported, but in the future, maybe we can support TCP, SCTP, or something else. And some other utilities we need is a timer, configuration tools. So this is some small components. So this is, I would skip this slide. It is just how to configure the geo-clustering. So this is some basic command in the geo-clustering. We can list the ticket currently in the environment, how many tickets we have, and we can grant a ticket to some site, or we can revoke the ticket from that site. So the product is hosted on GitHub. You can download it and try it. Thanks. Questions? Okay.
What part could a kind of a server like a cluster like this play in a disaster recovery plan?
Okay. For the recovery plan, I think because we have, if you want to recover the service from another site, so you should, because for different different site, you may have different topology of the class. You may define which resource should be ran at another site in whatever way. Maybe it is different way, because for the original cluster, maybe you have 3 nodes, but for the new cluster, maybe you have 2 nodes or whatever. So you should define which resources should be run as in what way, and this kind of job should be done in the CIB, which is a description file to describe the whole topology. So if we define all of this, and in the another side, the CIB is not the same as in the original side, but the result is the same. That for the new cluster, it can run all of the needed resources. And the most concern you may wonder is that for the data, if the data is available. So this is not the scope of the geoclustering. It just provides the service from the resource level. So for the data, maybe you can select DRBD proxy to do the data sync. Once the data is ready, you can easily let your service be running at another site very quickly. Because currently, if you have no the recovery plan, have no the set recovery, maybe you need several, maybe 2 days to recover the whole cluster. But if we have this kind of plan, maybe the time will even we don't use the automatic failover. Even let the admin to do this kind of job, the time should be reduced much. Okay, thank you. Yes, so this is as I said, it is the most concern which the Paxos algorithm should handle. That we should make sure that the decision is right. That for a ticket, we say the ticket is on set A, it should be in set A, not some set regarded in seen it as set A, but another set think it on set B. So this is the split brain. This is a disaster. So we should avoid it. So today I have no enough time to illustrate the whole algorithm and how we implement it. But my development goal is that develop that Paxos layer to be more general, which can be used in many other scenarios, because we can see this word very frequently. That like currently we like Google's Spanner, Megastore, or GFS or Ceph, many products, even it is open or not, they have used this algorithm very often. So what we need to do is that to stable the implementation and add the more missing features. So I think if have no time, I can illustrate the detail. Thanks. Thank you.
Thank you for your presentation.